good afternoon. Is it good afternoon? Yes, it's good morning. Good morning, everyone. We are still working on cylindrical coordinates. To remind you how this works, all the x's are replaced by r cos theta. All the y's are replaced by r sin theta. And you don't typically do anything to the z except replace it by r's and thetas when you can. In no particular order, the dx, dy, dz, which is in general just called dv in a 3D situation, gets replaced by an r, dr, d theta, dz, and you can mix and match them in order as well. I don't know how many times I've missed that little r when you do these questions, because if you don't have that in, doesn't your answer end up being something totally different from what it should be? Most of the problem is going to be when you do a double integral e of whatever the function happens to be, finding the limits of integration for that region E. That's going to be the problem, because once you set that up, it just ends up being a triple integral. Yes, Tim.
So when we did these for surface area and they were double integrals, you said that you would tell us when we got to triple integrals where that r comes from. Are we at a point where you could tell us where that r comes from, or
no? You have to wait till we do a thing called Jacobians, and Jacobians are change of variables in 2 and 3 double and triple integrals.
Okay.
So do you know how, like in Calc 2, you did u equals x squared plus 1? That was a change of variable. Well, when you move into double and triple integrals, you have to do a change of variable. And when you do that, they're called Jacobians. And so when we do that, you will see it. And it ends up being r. That ends up where the r is going to go. As far as I can recollect, did we get as far as 7? Because it looks familiar. 7 would be a cylinder, x squared plus y squared equals 9, and some kind of sphere. So it was a cylinder meeting up with a sphere.
I think the last one I wrote down was 4.
4.
The last one I have is 4 as well.
Okay, so I may have been familiar, but only because I was looking at it and not doing it. Okay, well, let's start at 5, because we're being asked to do a double integral over, a triple integral, I should say, over e of x minus y dv. Oh, side issue. Suppose you are finding the triple integral over e of dv, which basically is, you know, the triple integral over e of 1 times dx, dy, dz. What physical thing are you finding when you do a triple integral of 1?
Would that be volume?
Yeah.
the volume
You're
of a
finding
unit
the volume
sphere?
of, well, whatever E happens to be. It could be an egg or something, right? But you're finding the volume of E. If you do a double integral over some region R or D, it'll be called dA. So it'll be a double integral over R of 1, say dx, dy. What physical thing are you finding now?
Is that area?
Yes. Not surface area, but the area of, darn it, how to phrase this? It's just the area of R, right? That's the best way to describe it. The area of the floor, right? So if you had a floor region, that would be it. Now,
could we call it the area of one m arbitrary m slice of the object?
well, if you can imagine the floor being this shape and you moved 1 unit up, right? Isn't the volume of that shape also, the number for that volume, if you do it 1 high, isn't it the same thing as the area of the base? And so if you're doing the little things and you're doing 1 unit high, which is, I think, what you're talking about, you're adding up a whole load of those. And what that does, and because their height is 1, is get you the area. So just in case you see a question where it says, find the volume of this shape E, and you think, but I need to have a function here. When you see the word volume, it could well be 1. There are going to be other situations where it's different, but right now it would be 1. Now, what do we know about this? Well, this shape lies between 2 cylinders, which happen to have those guys, and a plane with equation z equals y plus 5, and it's above the xy plane. Right, so we're looking at some shape, some region E, which is made by those 2 cylinders. If you can imagine what that would look like, wouldn't it be a pipe? And this would be the xy plane.
So it looks like we'll be taking the triple integral of a washer.
Yeah, but just to make life even more awkward, it's not just a nice washer, because you're cutting it at an angle now as well. So it's like a very long pipe that's been cut at an angle. Quite a weird thing. And then you're going to do this integral of it. So we have to create E from this information. You know it's going to be cylindrical because all these questions are cylindrical, but isn't those 2 guys a big clue about cylindrical? Now, if you just put them on the floor, don't you get a double circle thing? And so I know what R is, and I know what theta is. The little radius is 1, the big radius is 5, and since it's the entire circle, we got that guy. That means there's only one guy left. We need to have a limit of integration for the z's.
Is it 5 to y plus 5?
Y plus 5. I like your y plus 5. But this isn't 5, although I can think of why you might think it's 5. Let's just check that. This is the clue. What is z when you reach the xy plane? I keep calling that the floor. What's the z value?
Oh, would it be 0?
Okay. So you put that package together, and you're going to be doing the integral from theta equals 0 to theta equals 2 pi. You're going to do the integral from r equals 1 to 5. Couldn't I switch those 2 around and it wouldn't matter too much, right? Although you got to see what's coming later. And then you're going to do the z's. And the z's are going to be from 0 to y plus 5. But shouldn't the z's be in terms of r and theta?
Yeah, then that should be r cosine. I mean, r sine plus 5.
Correct. Are you happy about that being y plus 5 converted into r's and thetas? Now, once that's done, won't the x become r cos theta, and the y will become r sine theta? And then your r, your dz, your dr, and finally your d theta. Now that I've set up the entire integral, I'm going to go back and do a double check on these. Superficially, I said you could switch these because they are numbers, right? Do you agree? And we should be able to switch them any way we like. Agreed? Would you agree this has to be first? You might think that you can separate this out, and in a way you can. But why can't I do a variable separable right now? I might do it next, but why can't I do it right now? What's the problem? See it there? This integral has r's and theta's in it, doesn't it? It's not a number. If I said, oh, well, I'll just pull out the r squared and stick it here, and I'll pull out the theta and stick it here, and then I'll just do this integral, with a 1. It doesn't work, right? So numbers can be switched, but if there's a variable involved, you can't really get around it. Now, once you've done this, or once I've set this up, isn't it just going to be our good old-fashioned integration? So let me show you some of the integration things that can and do happen. Sometimes you're going to have to integrate, say, this guy. Let's just say, for argument's sake, well, let's say I've already done the integration, right? And I've got this guy. Then later on, I need to integrate it, let's say, with respect to theta, right? So that's been pulled out. How do you integrate sine squared theta? Because I'm pretty sure you're going to see sine squareds and sine cubes and sine theta, cos theta combinations like that. This is from Calc 2. How do you integrate sine squared theta? You need to know a trig identity. What's the trig identity that is useful for integration for sine squared theta?
Sine squared plus cosine squared equals 1.
Well, that's just an identity, but it isn't any use to us right now. I want to know what to turn sine squared into. So I need an identity that says sine squared theta equals, insert blank here.
Would it be 1 minus cosine squared theta?
Well, that is correct. That is true what you said, but it's not much help to integrate, because then don't I have to integrate a cos squared, which means I'm kind of in the same place I started.
Is it 1/2 minus 1/2 cosine of 2x?
Okay, and I'm writing down essentially what you said, but I pulled out the half as a common factor. Yes, that is written down somewhere, or
Yep.
you have got a good memory, right?
Written down.
So let me remind you of those guys. And you can pull out the half, or you can call it a half minus a half cosine 2 theta, that's fine. You can also get this happening. What technique is not, well, there are 2 ways to do this. What technique would you use to integrate that? Which is the way my brain would work.
Can you do a little U sub?
Yeah. Which U sub are you going to use?
U being sine theta.
Yeah, actually the other one would work, but that's one I would do. Or you could recognize it as a half of the sine of 2 theta, which is an identity. So when you do these questions, especially the trig ones, right, the sine thetas and the cos squared thetas and so on, you're going to have to go back, I suspect, for some of you, and find out identities that can be used, or use sub techniques that can be used to get your answer. Are we okay with that question now? Right, let's move on to a region E that's described as inside that guy. The plane is z equals 0, and the other surface is called z squared equals 49x squared plus 49y squared. And we have to turn this mess into limits of integration of X, Y, and Z. Any starters? I'm looking at that one and I'm thinking that's a freebie. Would you agree? Because isn't that basically just a circle? And there's no indication it's in the first octant or anything, so it's a whole circle. Now, I need to get a range of Zs, and it should either have numbers or things with theta and or R's in them.
Is it
Wh-
0 to 7R?
Oh, I like your answer, which is correct. You want to share where you got it from.
Well, 0 was a given, and then I know that x squared plus y squared is r squared. But I square rooted it because z is squared, and then the square root of 49 is 7.
Right? Now, technically speaking, everything is correct because that is the right answer. But when you take a square root, couldn't that have been plus or minus 7r? But
Yes.
because of this, we know we can only use the plus. Can you imagine the same question, but they did that to you? That bit was missing, right? So the same information, but you're not told that z had to be 0. Wouldn't this now be negative 7r to 7r, right? But you nailed it. So our integral is going to be r equals 0 to r equals 3. Our theta equals 0 to theta equals 2 pi. And our z is going to be from 0 to 7r. Now I have to look at the question. And you were being asked to do x squared. So that's going to be r squared cos squared, because that's what x squared looks like, times an r, a dz first, in my case a d theta, and you finish with a dr. Are we comfortable with that particular question? Sometime you are going to have to deal with a cos squared theta. And when you integrate that cos squared theta, won't you do that half 1 minus 1 plus the cosine of 2 theta to do it? Okay. Next one. This is one I said I thought I remembered. The region E is the points inside the cylinder and interacting with a sphere. So if you can imagine this as a sphere, and they have got a cylinder kind of boring its way through the shape. So our region is basically a sphere with a hole drilled in it, a vertical hole drilled in it. Now, we've got to figure out E. Would you agree one of those two guys here are candid twos on a plate again, aren't they? What would the range be for R and theta based on this story?
Would it be from 0 to 3 and 0 to 2 pi?
Because if you talk about everybody inside one of them, isn't that what you get? Now, we got a Z problem. Right? So what is, how are we going to get the range of Zs?
So, we would manipulate the equation of the sphere.
Right.
To get z equals the square root of 49 minus x squared minus y squared.
Okay. And remember, our goal is to get things with R's or thetas, and them or both, I guess. So what happens next?
Then that would become 49 minus r squared.
Great. And remember, Tessa, you did the square root one and got the 7r and said in that case it was right. Do you notice in this case there's no mention that z has to be positive 0 or anything else? So when you take the square root, aren't you going to get both a plus and a minus? So in this case, you're going to have a negative on this side and a positive on that side. That makes sense. Now the integral that you're going to end up doing then is going to be z equals this ugly guy to z equals this ugly guy. The function that we're meant to do it is a volume, so that just means 1, right? When you do a volume, it's a triple integral of 1. The r is going to be 0 to 3, and the theta is going to be 0 to 2 pi. We are going to do r dz dr d theta. I'm going to take this one a little bit further. If you integrate 1r with respect to z, you will just get zr. Evaluated at this ugly square root and that positive ugly square root. And we get that. So you're going to have theta equals 0 to theta equals 2 pi. You're going to have r equals 0 to r equals 3. And when you plug in z for this guy, take away z for this guy, you get this guy, take away a negative of this guy, you end up with 2 of them. So once you've got rid of
prettier, because then the twos just cancel out.
Oh yeah, yes, you're right. I would probably separate this. And you're quite right, they are going to cancel it. But that's going to take a little bit of time. How will I integrate this ugly thing? This is calc 2. How do you integrate that?
That would be the u sub with the 49 minus r squared being u.
Yeah, and you end up with something like negative the square root of u, and then you can integrate it and do all the things you need to do. But that'll be a number, and this guy here is just going to be 2 pi because it's easy to integrate. Are we cool? As you've noticed, I'm only focusing on getting the limits integration, because once you've done that, hopefully we've done so much practice at triple integral evaluating them that you'll be able to do that bit without so much trouble. So here is another one where we've been asked to find the volume, and the region is this guy, which I believe is a cone, and it's interacting with this guy, which is definitely a sphere. God, can you imagine somebody took a cone, took a sphere, and bored a conical shaped, I know what you'd call it, hole in it, right? That would be what, a ball bearing with a conical hole in it. Who knows, one day somebody might actually want a ball bearing with that particular weird shape, right? But right now we're just going to figure its volume. So we need to set up that guy. Let's check if there any other information. No, okay. Give me a place to go. I need a place to go here. X, Y, or Z, don't really care, but can you tell me one limit of integration?
The
upper
you
limit.
square.
Well, we get two people. Who was first? I couldn't catch.
Go ahead, Rosie.
All right,
So the
Rosie, what you got?
The upper limit of z is going to be the square root of 50 minus r squared.
So you're going to take this guy and you're going to do z squared equals 50. Take away that guy, take away r squared. So far, so good, right? But don't we need a z? So where are we going with this?
So it's going to be square root of 50 minus r squared.
In this case, we're going to have a top limit and we're going to have a bottom limit. So what does z equals the square root of x squared plus y squared give you? What kind of z relationship does that generate?
Square root of r
Right.
squared.
Is it square root of r or square root of r squared, which is just r?
Oh, it's just r.
Just r. Now, I'm going to go, because I can see it in front of me why they did it. I like that. That's a good start. Now, somewhere in here, they told me, and I can't see it, so I'm assuming that this entire shape is above the XY plane, which kind of makes sense because the cone finishes at the origin, right? You're not going to do anything else under it. A cone pivoted on the origin. That's what that would look like. So now we have to figure out who these two guys are. And all we've got to work with is that. Any ideas?
If you square z and square the other side of it,
Mm-hmm.
then would our circle be from 0 to z? The
No,
radius.
I like this bit. This is good. This is a good start. Now I'm just going to write down the other piece of information underneath it. So
And
I
then
want to
we could-
use this.
Could we substitute in the x squared plus y squared for the z squared?
Yeah. And you end up with 2x squared plus 2y squared equals 50. Essentially what we're doing is we're setting these equal to each other and seeing where they intersect. Because where they intersect is basically going to be the shadow on the ground. That's going to be the xy guys. In this case, do you see a circle of radius 5?
Yep.
And so radius 5, the whole circle. See how that one was quite sneaky, right? So if you get a question where all the information really seems to have z's in it, and you want to try and figure out what the xy's are, because that's going to be the floor, and then turn it into polar after that, find a way of setting these equal to each other. Find how they intersect. Does that make sense that a cone going upwards with a sphere around it, when it finally pops out the other end, wouldn't it make a circle? Imagine a cone cutting through a sphere, it would make a circle. So it kind of makes sense that it's that circle. And so you're looking for a volume. So it's going to be z equals r to z equals this guy. It's going to be r equals 0 to r equals 5. It's going to be theta equals 0 to theta equals 2 pi. And since it is a volume, it's 1 of r dz dr d theta, right? And can I dot that? I bet you're going to have another one of those u sub situations, you know, where u is r minus 50 minus r squared, and Bob's your uncle. It's another volume question. I'm beginning to get deja vu on this one. Yes. Z is equal to x squared plus y squared. And x squared plus y squared plus z squared is equal to 2. Now, same problem every time. We're being asked to get a volume. So I know it's going to be a triple integral over this region of a 1. Right? This is essentially, isn't this the same kind of problem that we have where all the information is really with z's. Would you agree that this one is z equals r squared? Right. If you rearrange this one, aren't you going to get z squared equals 2 take away r squared? And so won't that make z equal to that guy? Are you comfortable with that? And I'm going to make the assumption that it's positive because it kind of has to be. But that's only got one of the limits of integration sorted out. And I'm just making sure I've got them the right way around here. And the little guy goes here. And the sphere goes there. Of course, if I got them wrong, which is very easy to do, won't I just get the answer -10, then I'll fix it and call it 10. So if you get one of them back to front, since you know it's a physical volume, because I'm not sure it's obvious, at least to me. If you put it into GeoBra, you could look at the thing and you'd see, okay, this guy is higher up and the other guy is lower down. You might be able to judge it that way. But we're still now on this guy. This is a little bit messier than the first time. The first time ended up being a circle. I have z equals x squared plus y squared. And I have x squared plus y squared plus z squared equals, I think it is 2. And we need to get this thing sorted out, right? In some way that we can find out what the x, y's are in terms of r and theta. So where are we off to? By the way, this is question 9.
If we manipulate the x squared plus y squared plus z squared, similar to the last question, don't we end up with r squared equals 1?
Oh, you do enter up with something quite interesting. And that may be the case, and I'm pretty sure it is. I'm just going to make it a little bit harder by proving it. So what I'm going to do is I'm going to take this guy and put him in here. So it's going to get a lot uglier before it gets nicer. Okay. So far, so good. Now, if I'm picking up your brain correctly.
Yeah, I just missed that it wasn't z equals the square root of x squared plus y squared.
Right. So now you've got an r squared plus an r to the 4 equals 2, which I'm going to call r to the 4 plus r squared take away 2. And what does that get me? Well, it gets me it gets me well, I can't really call it quadratic, but essentially it is. It gets me a quadratic, but what's going to come out of it is 2 values of r. So I'm going to do an r squared and an r squared and a plus somebody and a minus somebody. And if I do a plus 2 and a minus 1, are you comfortable that that's the factor of this guy? Actually, you could plug it into Desmos. And when you do, you only get 2 answers. So I have now found out what r is, or at least what I believe to be r, which is that guy. But which one of those r's is actually a true value of r, a usable value of r? When you talk about the radius of a circle, do you ever say -1?
No, so it would just be from 0 to 1.
Okay, and I'm just doing that because I know that certain values don't work. To give you another example, won't this one be r is square root of 2i and r equals negative the square root of 2i? Would you be much more comfortable about killing those two because nobody gets complex numbers at radius, right? And in the context of this, we know that we're dealing with we're doing circles, so we know the r is positive. So the only guy that's left, I guess, is what is that? Well, if you do all the points whose r is equal to 1, Isn't that basically a circle radius 1? And a circle radius 1 is 0 to 2 pi. Are you cool with that last little, how I figured out theta was? Because r equals 1 isn't just a solution to an equation. R equals 1 represents all the points on the floor whose radius is 1. And since it's all the points, that means theta from 0 to 2 pi. Any questions about the logic I used to generate those three guys? Are we good? I'm looking at puzzled faces. Tessa, what doesn't make sense?
I think I just need to let that sink in.
Sink in. Gotcha. Not a problem. You set up the triple integrals. I don't want you to set up the triple integrals because you know what they're going to be, and it would just take a little bit of time. And since it's a volume, won't it just be 1? And since you've got this guy, aren't you probably going to have to do another U sub like the other 3 questions ended up being? And, ooh, this is going to be quick. I'm going to do a center of mass question. Or at least I'm going to get it started. And the center of mass question in this case is a parabola. With that equation. And the plane z equals a. And we need to calculate the mass, which is the triple integral over this region E. The function has a density function. Oh, that's good, of a fixed number k. So the mass is going to be triple integral of k. And I know I'm going to do polar because all these questions are polar. So I'm going to put in the r, dz, dr, d theta. And now I can focus on each one of the 3 limits of integration. And I'm going to do r, I'm going to do theta, we're going to do z. Let's do the baby one. I mean, that should be a number, right? A is a number, you just don't know what it is, it's a constant. So can we say that it's A? And what will z equals x squared plus y squared look like if you do it in terms of r and or theta?
That would be z equals 7r squared.
Right, are we happy with the limits of integration for the z's? From a to 7r squared. Now we need to get the x's and the y's. And all I know is that this and this interact. And this time, if you put them together, you get 7x squared plus 7y squared has to equal a. Do you agree? Which means that x squared plus y squared has to be a over 7. Would you agree you are basically looking at a circle with a weird radius? And the radius of this circle is the square root,
over 7.
which I'm going to call the square root of, no, I'm just going to call it square root of a over 7 because it's downright ugly, isn't it? You could call it that if you want. I'm not sure if there's any benefit, but that's the guy. So I know that the radius, because it's a circle, goes from here to the square root of a over the square root of 7, and it's a whole circle. We got it. So far, so good. So I'm just going to keep going for as much time as I can, and then we'll kind of have to call it quits at the end of this whenever that happens. So it's going to be from 0 to 2 pi, from 0 to the square root of a over the square root of 7. Now you might think that's a variable, but square root of a is actually just a number. So these are both numbers. And the z's, well, we already got the z's. They go from a to 7r squared. The density function r, a dz, a dr, and a d theta. So I've got these two guys. And this fella. So what do you get? You get k times z evaluated at a and at 7r squared. Oh, times an r. Almost missed it. And then you're going to do dr d theta. K times z is going to be k times 7r squared times another r. Take away k times a times an r, dr d theta. And this is going to be not a lot I can do with this, but I'll try my best. What can I do with it? I can get 7kr cubed times kar dr d theta. Isn't this k a constant? Right. So I'm going to pull that guy out and give it to the thetas. And then I'm going to do r equals 0 to that guy. And it's going to be 7r cubed, take away ar dr. Now, if you do this one, you'll get 2 pi k because it's easy to do. And if you do this one, yeah, time beat me. Won't I be getting 7/4 r to the 4, take away 1/2 ar squared, evaluated at that ugly guy, and that get, oh, guess what? That ugly guy actually becomes nice. And that ugly guy becomes nice. So this will actually be pretty reasonable. And all we found right now is the mass. Now, you need to find these three guys in any order you like. And this guy's going to be the same triple integral, but with a z in front of it. This is going to be the same triple integral with a y in front of it. And this is going to be the same triple integral with a k in front of it. So you'll use the same limits of integration, but instead of integrating k, you're going to integrate k r cos theta, k r sin theta, and this time k with a z, and you figure out who z is, and you're good to go. Anything else I can do about this guy? Well, I can cheat a little bit. Since z is 7x squared plus 7y squared, would you agree that this function is symmetric in the z's, in the x's and y's? If you have that, if this guy, I'm making it up, but if you wanted to find those three guys, if this guy is 7, so will that guy be 7. This guy here could be anything. But doesn't that at least save you one little piece of working? Now, if the shape was completely symmetric, if it was like an x squared plus y squared plus z squared equals 9 kind of thing, wouldn't you only need to find x bar in this particular story? Because the other two by symmetry would be the same. Now, that works because this is a k, right? If this function here is also symmetric, then you can do it for every situation. But we can only do it right now because that is essentially a number. Numbers are symmetric because they don't contain any x, y's, and z's, so they work all the time. Whew. I feel like I'm talking a lot today. Right, so, and I'm sure I have. last name, bye-bye. Your grade to your test is online. And I haven't yet got round to the bit where you can see your solutions and, you know, check the answers, but I will try and get that done later. And I also have practice midterm, I should say, and some other stuff. So if you go look at Canvas, you'll find lots of goodies to get you ready for your midterm this coming Monday. Okay, guys, bye-bye. I'll hang about for any questions.
Thank you.
Bye, thank you.
Bye.
Bye-bye, guys. You got a question for me, Tim?
Sorry, I was looking at my test score actually, and I just wasn't paying attention.
That's fine.
Have a great day.
You too. And I say I'll see you later then.
Yeah, I'll see you later.